In this class, we're going to take a look at how you deal with fractional powers. So a power normally tells us how many times to multiply a number to itself. So for example, 4 to the power of 3, that just means 4 times 4 times 4. So in other words, we multiply 4 to itself 3 times, and then we could process that. That's 16 times 4 again is 64. So that's how we're used to working with powers. And if you've already taken some classes working with these powers, these exponents or indices you might call them, then you might as well also know how to process a negative power, which is less intuitive. So this says multiply 4 3 times. How do you multiply 4 to a negative power? You can't multiply 4 to itself minus 2 times. So you change this into 1 over 4 to the power of 2, and that becomes 1 over 16. So we know how to process positive powers by using this little rule, which we're not focusing on here necessarily. We know how to process negative powers. But what about fractional powers? What do they mean? So if a power tells you how many times to multiply the number to itself, how do we multiply 4 to itself 1/2 times? So that's quite difficult to get in our heads. But it basically turns out that there's a connection between fractional powers and roots. So surds, that is, or radicals you might call them. So we'll look at a couple of examples, and then we'll think about the kind of general case in a moment. But the key really is to know that if you've got some base number a, in fact, I think it's maybe just the example I've got here, which I might just pull out for now and put over here. If you've got some base number a with a 1 over b power, okay, so we'll deal with numbers in a moment. We'll just start with these general ideas. That can be changed into a root, the root of a, but not just a square root necessarily, but in this case, like a bth root. So that sounds a bit weird, but that would be like a b in there. So let's concretize that a little with an actual example. So let's say you had a to the power of 1 over 4. So a 1/4 power, we just change that into the 4th root of a. So it just goes basically like that. Similarly, if you had, say, a 1 over 7 power, then that would just be the 7th root of a. So that works like that, and it works in both directions. So if you had a 1/4 power, you could turn that into the root equivalent. If you had a 7th root, you could turn that into the fractional power equivalent. So it's setting up these equivalences that is going to allow us to process these fractional power numbers. So taking that idea and moving over to these examples, here we've got 4 to the power of 1/2. We don't really know how to do that, but we can switch that into a form that we do know how to process, which is a root form. So the 1 over 2 power is just a square root. So with square roots, we tend to not put the 2 in there. You could write the 2 in there just to bring whatever number is here down to the placeholder, which tells you which root you're dealing with. Generally, we don't do that though. A 1/2 power is a good one to remember because a 1/2 power is just a square root, which we're already familiar with. Square root of 4 is 2. So that's just telling you 4 to the power of a 1/2 is 2, because it's just the square root of 4. Similarly, 8 to the power of 1/3 is just going to be the 3rd root, the cube root that is, of 8. So that's the number that multiplies 3 times to give you 8, so the answer to that is 2. So we're just applying this rule. We're just saying that if it's a 1 over whatever power, then we make it into that type of root. So in general, a 1 over b power becomes the bth root, I suppose. 1 over 3 power, the 3rd root. 1 over 4 power, the 4th root. So that's fine when you've got a form of 1 over, but what happens when you've got some other number on your power? Well, what we do in these scenarios, we think of some of the indices rules, in particular the rule where, let me actually just maybe write this down here and use some general terms. So you've got these rules for indices which say that if you've got a to the power of b raised to a further power of c, then in that scenario we make that a to the power of bc. But remember that these indices rules, like most rules, go both ways. So either turning this guy into that guy or that guy back into this guy. So this doesn't obviously look like either of these, but a power of 3 over 2 you could think of as 3 times 1/2. So we could imagine this guy here actually being in this form, and we want to turn it back into the other form. So we can say that 16 to the power of 3 over 2 is just equal to 16 to the power of 1/2 raised to the further power of 3, in other words, cubed. So 16 to the 1/2 cubed, because 1/2 times 3 is 3 over 2. So we've just used that indices rule, that exponent rule going backwards. Now it's in a form that we know how to process, because we know that a half power is the same as a square root. So we can say, okay, that's fine, that's just the square root of 16 to the power of 3. Just going to go ahead and move my other example for now. 16 square rooted is 4, so that gives us 4 to the power of 3. That we can process as well, 4 times 4 times 4. The answer for that is 64. So that's basically what we do with those. It's like one added extra step from doing these guys. So the ones where you've got a 1 over power, you just go straight to the type of root. The ones where you've got something else on the top of this fractional power numerator, you just split it up first of all and then process it like these guys here. So I think the other example I had there was 81 to the power of 3 over 4. So again, we're just going to do the same thing. We're going to say that's 81 to the power of 1 over 4 cubed to the power of 3, because 1/4 times 3 is 3/4. So that's always going to be your first step with these, splitting them up in that way. Still quite difficult to process this one. That's going to be the 4th root of 81, which is not a number that we would, commonly just know off the top of our heads. As you do more and more of these questions, you'll start to see a lot of the same numbers. So 81 is actually quite a common number in these questions. The 4th root of 81 is 3, because 3 times 3 is 9, times 3 is 27, times 3 again is 81. You'll probably see that number fairly regularly. So that inner part there, the inside of that bracket is just 3. We leave the power of 3 on there. So 3 to the power of 3, 3 cubed is 27. So we can say that in general, so this was our first rule when it's 1 over on the power, and we can say that in general, if you've got a to the power of b over c, then we're going to split that into the a to the power of 1 over c to the power of b. That inner part then just becomes the sort of cth root, I don't know how you say that, the cth root of a to the power of b, like that. One thing to know about these, if you are processing a fractional power like this, where it's not just 1 over, you've actually got the option of processing these in either order. So the way that we did this example, we took the square root and then we cubed it. But you could cube it and then take the square root. You'll get the same answer, but if you're doing this question non-calculator, which is what it would be, then cubing 16, that's not good, right? That's 16 times 16 times 16, and then square root in that number to get 64. That ain't going to happen, right? Because that's a really big, ugly number. So you're better to take the root first, the inner part, and then apply the power. With smaller numbers, you might be able to get away with it. So for example, if you had 4 to the power of 3 over 2, let's process that both ways. So we'll start by making that 4 to the power of 1 over 2 cubed. 4 to the power of 1 over 2, that's just the square root of 4, this guy here, which is 2. So that's going to be 2 cubed. 2 cubed is 8. So in that case, we did the root part first. I just skipped the line when I made it into a root, but that's basically the root part. If we did it the other way, then that would be splitting it up as 4 cubed. So taking the power of 3 first and then applying the half power to that. So swapping the order. 4 to the power of 3 is 64. The half power is a square root. Square root of 64 is 8. So you get the same answer either way, But generally, for most numbers, apart from very small numbers like a 4, you're going to want to take the root first and then apply the powering up. Quite important, these fractional powers come up more often than you might think, especially if you move to maybe like a pre-algebra and then a pre-calculus and then a calculus course, or even an algebra 2 course. You're going to see quite a lot of these. They are popular. They're quite difficult at first because you're just not quite sure of the order of things. Worth spending a bit of time practicing these, and when you see them again in the future, they'll be less scary and you'll just be able to process them according to these rules. There's not that many rules to learn. There's only 2 or 3, but the challenge is seeing those rules in different scenarios so that you don't freak out when you see them in a scenario that you've never seen before. The rules never change, it's just really the scenario that changes, and then you've just got to be comfortable enough to be able to apply the rule without freaking out. So practice a few of these, check out a few practice questions.